All right, so today we're looking at 3.2b graphing log functions. So this is the last section before we have a test. But tomorrow is the reward day, so you won't have any new assignments. Monday, you'll have a review of 3.1 and 3.2, and then Tuesday a test on it. So graphing log functions is very similar to when we graphed exponential functions in 3.1. The difference being that a log function is the inverse of an exponential function. So if you remember, inverse functions are functions where x and y trade places, the inputs and the outputs trade places. So what we're going to be looking for on this is the base. So on this first one, we have y equals log base 3 of 10. 3 is our base. That's going to be kind of giving us a starting point. So like on number 2, log base 2, this 2 is our base. The reason that is going to help us is because the inverse of this function is 3, or y equals 3 to the x power. And this is what we've already graphed. And when we did this, when we graphed y equals 3 to the x, we knew that 0, 1 was always a point on the graph, and also 1 base, or 1, 3 was always a point on the graph. So these were our two starting points for where we moved when we had transformations like +5 and +4. These were the 2 points that we started with and that we moved around. Also, y equals 3 to the x has a horizontal asymptote at y equals 0. So these things were basically the things that got transformed. We're going to be doing the same thing here with log base 3 of x. But because it's the inverse of y equals 3 to the x, that means x and y are swapped. The 2 points that are always going to be on the graph are the inverse of these. Remember, inverses just switch x and y. So 1, 0 will always be on the graph. And then also, whatever our base number is, 1. So on the exponential function, it was 1 base. In this case, the base was 3, so 1, 3. The 2 points that will always be on a log function are 1, 0, or the parent log function are 1, 0, and b1. B being the base, in this case 3, so 3, 1. So like on number 2, it would be 1, 0, and 2, 1. And then the horizontal, that doesn't have a horizontal asymptote, instead it has a vertical asymptote at x equals 0. Okay, so the parent function always has a vertical asymptote at x equals 0. So since this one right here, log base 3 of x, has no transformations, it will just have its vertical asymptote at 0. And then the 2 points 1, 0, 1, 0, and base 1, in our case 3, 1, right? So 1, 2, 3, 1. Those 2 points will always be on the graph. This one is going to come and approach that asymptote going down, and then it's going to go over to the right. Okay, so just as a comparison, let's sketch the exponential 3 to the x. That one had a horizontal asymptote at y equals 0. It had the point 0, 1, and 1, 3, right, on the graph. It hugged the horizontal asymptote and then headed upward. Okay, so this is an inverse of that. So the asymptote is now vertical and the points are just swapped. Okay, so if we're looking at number 2, the 2 points that I'm going to be transforming are 1, 0, always 1, 0, and then whatever the base number is, in this case 2, and then 2, 1. And then it would have a vertical asymptote at x equals 0. So this is just if it were the parent function, if there was no +5 here or +4 here. These are the points and the asymptotes. Now, however, we know that this +5 on the inside is going to move everything left 5, and we know this +4 is going to move everything up 4. And so we're going to take these things and make these transformations on them. So since everything went left 5, this vertical asymptote that was at 0 is now going to be at -5. changing up and down is not going to affect the asymptote at all, but just the left and right movement. Okay, and then there's 2 points on here, 1, 0. So right here, but I know that point goes left 5, 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. So it would be right here at negative 4, 4. So this point transforms to negative 4, 4. And then 2, 1. 2, 1 is also going to go 1, 2, 3, 4, 5 left, and 1, 2, 3, 4 up. So it's going to go over to negative 3, 5. Okay, so that transforms to negative 3, 5. Give me these 2 points once they've been transformed. And then just sketch the graph. It's always going to go along the asymptote and then head over to the right. This actually also asked us to state the domain and the range. So the domain is side to side, so it's always going to go from whatever the vertical asymptote is to infinity. The range, this is the domain. The range is going to be this exact same on every one of them, negative infinity to infinity. Okay. All right, so on number 2, the domain goes from negative 5 to infinity. So wherever our vertical asymptote is to infinity, unless of course there's a negative out front which flips it the other way, which I don't think any of them on this one do. And then the range is always negative infinity to infinity on these. Okay. So state the domain and range, give me the 2 points of where they got transformed to, draw the asymptote where it should go, and then sketch the graph. Okay, so here we have base 3. So I know the points 1, 0 and 3, 1 are the 2 points I'm transforming. The vertical asymptote is going to go right 1. So usually at 0, 0, but because everything moved right 1, it's going to go right 1. So right 1, up 3. So 1, 0 is going right 1, up 3. So it's going to be at the point 2, 3. So that one transforms to 2, 3. 3, 1 is going right 1. Let's see. 3, 1 is going right 1, up 3. So it'll be at 4, 4. So this one transforms to 4, 4. Okay, so just give me those 2 points. Make sure you sketch in where the vertical asymptote should be, and then sketch the graph. And then try to hit your points. And then the domain goes from the vertical asymptote to infinity. The range, always negative infinity to infinity. Okay. So on number 4, my base is 6. So 1, 0, 6, 1 are my 2 points that are being transformed. My vertical asymptote is usually here at 0, but it's going left 5. So I'll sketch that in. Okay, 1, 0 is going left 5 and down 5. So at 1, 0 I go left 5, 1, 2, 3, 4, 5, and I go down 5, 1, 2, 3, 4, 5. So at negative 4, negative 5. Okay, another way to do that is if I'm going left 5 on x, subtract 5 from the x value. So 1 minus 5 is negative 4. If I'm going down 5 on the y value, I would subtract 5 from 0. So instead of like running around on the graph, which if that's easier to you, do it. I could just take 6, and since I went left 5 from 6, I could subtract 5 from that. And 1 going down 5 from 1 would be 1 minus 5, which would be negative 4. So 1, negative 4 would be the other point here. And then just sketch it in like this. The domain is negative 5 to infinity. And the range is negative infinity to infinity. All right, so let's just do one more, and then I just want to give you a couple other pointers before we end here. So our base here is 6. let's actually do number 6 instead. So our base is 4, so we have the points 1, 0 and 4, 1. Those are the 2 points that are going to be transformed. Since everything went left 2 and down 2, my asymptote would move from 0 over to negative 2. That's the left 2 that does that. Since everything's going left 2 and down 2, means we need to subtract 2 from each of our subtract 2 from our x's, subtract 2 from our y's. This would be 1 minus 2 is negative 1. And then 0 minus 2 is negative 2. So negative 1, negative 2 is one of my points. And 4 minus 2 is 2. 1 minus 2 is negative 1. So 2, negative 1 is my other point. And then just sketch it in there. The domain goes from negative 2 to infinity, and the range is from negative infinity to infinity. All right, so just a couple of things. If you have a log that does not show a base, so something like log x plus 5 minus 2 or something like that, you don't see a little number down here. Remember, the standard base is a 10. So if you don't see it, it means it's log base 10. Okay. If you see ln of x, maybe it will have other things like this. That means our base is the number e. It just doesn't show it when you do ln. It assumes you know that. And e is approximately 2. Let me just remind myself, 2.7 or something like that. So e, yeah, 2.72 if we round it off. 2.718. So if you ever have natural log, then you would have to consider that base as 2.72. If you have any questions, please don't hesitate to email me. I hope you have a great weekend.